following along, taking notes, we're on page 24 in your packet. Now, as a review, we have already explored two ways to solve right triangles. We've talked a little bit about the Pythagorean theorem that helps us to find side length, and we've talked a little bit about trig that helps us to find side length and angles. Another way to solve right triangles is if you have special right triangles. There are two special right triangles. The first one is a 45, 45, 90 triangle. Now, the key to special right triangles is memorizing the rule for each special type. So, in a 45, 45, 90 triangle, we have a leg, and a hypotenuse. Now, the rule here is that each of your legs are your 45-degree angle spots. So across from the 45 degrees, there's leg 1, there's leg 2, and there's your hypotenuse. So how I write my rule out to memorize this each time is I write that I have a 45, 45, 90 triangle. So my rule is x, x, x square roots of 2. So what that shows me is I actually have an isosceles right triangle. An isosceles triangle, remember, has two of the side lengths that are equal, and those two side lengths produce the base angle theorem where your base angles are also congruent. I'm going to use this rule to solve these three examples down here. So looking at the first one, I have a special right triangle of 45, 45, 90. So I'm going to write that rule down. 45, 45, 90. Remember that rule is x, x, x square roots of 2. So the side lengths that are my x's, again, are across the 45-degree angle. So they've labeled one of my side lengths 4 square roots of 3. I'm just writing it 4 square roots of 3. They labeled one of my other side lengths x. That's what I need to solve for. And then they labeled my hypotenuse as y, a different side length that we need to solve for. Okay. So by lining them up, you're recognizing the rule that you need to have. Well, they've named one of the side lengths 4 square roots of 3. So that must mean the other side length has to be 4 square roots of 3. My hypotenuse, my side length across the 90 degrees, has a rule of x square roots of 2. So right now, if I write this off to the side, I'm going to have y equals the side length that I'm missing equals x square roots of 2. Well, I need to fill that x in with something. That x represents my side lengths here. Or my side lengths are now represented or have a dimension of 4 square roots of 3. So I'm going to write this as 4 square roots of 3 and then the square root of 2. Now, mushing means to multiply, so I'm multiplying 4 square roots of 3 times the square root of 2. So radical multiplication rules tells me to multiply the outside to outside. The inside radical piece is 3 times 2 is 6. And 6 is the smallest radicand that I could have. So I have found the length of my hypotenuse. Let's look at the next type that we could have. Okay. Again, let's write my rule down. I have a 45, 45, 90 triangle. Well, Ms. Walsh, how did you know that? Well, they've marked both of my side lengths to equal the same. So again, that produces a isosceles triangle, so I know my base angles have to be equal. That rule is x, x, x square roots of 2. Again, they've given me a side length to solve for. They've given me a side length to solve for, so that's x and x. And the hypotenuse, they actually gave me the true dimension that they're using. That's 2 square roots of 2. Now, if you'll notice, this 2 sits in this x spot. Well, this x and this x and this x are all the same. So what that tells me is my side lengths are equal to 2. The third example is very similar, but we're going to have to apply another radical rule. So again, these 2 tick marks mean I have 2 congruent side lengths. So I'm going to have a 45, 45, 90 triangle. Again, that rule is x, x, and x square roots of 2. They want me to find one side length. They've labeled it x. They want me to find one side length. They've just happened to label it y. And again, they gave me my hypotenuse, which is 9. Well, 9 doesn't tell me very much about what my side length is going to be. So we're going to need to solve for x. So what I'm going to write is I'm going to write 9 is equal to that rule of x square roots of 2. If I can solve for x, then I can solve for my 2 missing side lengths. So to solve for x, we're just going to divide by the square root of 2. So remember that these cancel. And I'm going to have 9 square roots of 2 equal to x. Now, my radicand or my radical expressions rule tell me I cannot have a square root sign underneath the house. Excuse me, in the denominator. My 2 is underneath my house. I cannot have a radical expression in my denominator. So I have to do what is called rationalizing the denominator. So I'm going to multiply by the square root of 2. And what I do on the bottom, I have to do on the top. This becomes 9 square roots of 2 over the square root of 4. Well, what's the square root of 4? It's 2. So this becomes 9 square roots of 2 over 2. And that is equal to my side lengths. 9 square roots of 2 over 2. 9 square roots of 2 over 2. Those are 3 common examples or 3 ways to solve special right triangles using that rule for 45, 45, 90. The other special right triangle that we have is a 30, 60, 90 triangle. A 30, 60, 90 triangle has a different set of rules. I'm trying to make this straight for y'all. Those rules are we have a short leg, we have a long leg, and then we have our hypotenuse. So I'm going to label this out again for my rule. I have a 30, 60, 90 triangle. Now we've talked about triangle properties. Your hypotenuse is technically your longest side length, okay? But that's your hypotenuse because it's across from the biggest angle. So your short leg is across from the smallest angle. Your smallest angle is 30, so that rule is x. 60 is your next longest leg, because your hypotenuse isn't considered a leg, it's your hypotenuse. So 60 is the longest leg, that's going to be x square roots of 3. And your 90-degree angle, so your hypotenuse is worth 2x. So that's the rule we're going to look at. Okay. Again, if you look at your picture here, they've labeled it the short leg, x. They have the long leg, x square roots of 3, and your hypotenuse. So let's look at these 3 examples. I have a 30, which forces a 60, 90 triangle. So I'm going to write my rule. I have a 30, 60, 90 triangle. This is x, x square roots of 3, and 2x. So if I look across from my shortest leg, I have 2 square roots of 3. My longest leg, I have a y, so I'm solving for that. And my hypotenuse is x. So everything's going to start with my shortest side length because that's the side length that I was given. So just like before, all 3 of these x values are the same. So I'm going to use 2 square roots of 3 and substitute in for each of these rules. So my y value, my longest side length, is equal to x square roots of 3. So for that x, I'm going to substitute in 2 square roots of 3, and that's going to be multiplied by the square root of 3. So what should that give us? If we follow those radical expression rules, that should give us 2 square roots of 9. But what's the square root of 9? 3. So when I take that square root and I bring it out here, I am multiplying. So y is equal to 6. Now we have the hypotenuse to deal with. Your hypotenuse is x. X is going to equal that rule of 2x. Again, like stated before, these x's are the same. And we've said our shortest side length is 2 root 3. So this is going to equal 2 times 2 root 3. So in this case, I'm going to get 4 square roots of 3 as my hypotenuse, as that missing side length labeled x. Let's continue. Another 30, 60, 90 triangle. So I'm going to rewrite my rule, 30, 60, 90. That rule is x, x square roots of 3, and 2x. So again, I'm going to look for my shortest side length. My shortest side length is across from the 30-degree mark. So that side length is x. I don't know it yet. My longest leg is 5 square roots of 2. And my hypotenuse I'm solving for, again, they've labeled that y. So now I need to use the longest side length to find my other 2 sides. So my longest leg is 5 square roots of 2. But again, these x values are the same. So in order to find my shortest leg, I need to solve for x. So this is going to be x square roots of 3 is equal to 5 square roots of 2. So to solve, I'm going to have to divide by the square root of 3. So this cancels. So I'm going to have x is equal to 5 square roots of 2 over the square root of 3. But we've talked about this previously in this video. You cannot have a radical in the denominator. So we're going to rationalize it. I'm going to multiply by the square root of 3 on the bottom and on the top. So it's going to give me 5 square roots of 6 over 3. 3 times 3 is 9, but we know the square root of 9 is 3. So this is the answer to my shortest side length. X is equal to 5 square roots of 6 over 3. Well, if I know what x is, I can now solve for my hypotenuse. So remember again, your hypotenuse rule is that it's equal to 2x. And we've solved for x, so I'm just going to substitute this is 2 times that 5 square roots of 6 over 3. 5 times 2 is 10, so my hypotenuse is 10 square roots of 6 over 3.